everyone. Thanks for joining us today. We are with Dr. Timothy Chung, who is DARPA's program manager. Dr. Chung, can you tell me a little bit about yourself?
Sure. Well, thanks for having me. I'm really excited to chat with you all. As you probably mentioned, my name's Tim Chung. I'm a program manager, one of close to 100 program managers here at the Defense Advanced Research Projects Agency, or DARPA for short. And I have the good fortune of being the program manager for a couple of different programs that predominantly work with robots. And I'm a robotics engineer by background and training, but also by passion, and just, love learning about and working with robots.
Perfect. Our second question is, what's been your favorite technical project to oversee in recent years?
Yeah, thanks. I like basically any chance that I get to learn and push robotics technology. I think has just been really exciting, and had the great fortune to be able to do that on a couple of fronts. One of the more recent ones and ongoing efforts is the DARPA Subterranean Challenge. This one is essentially, how do you get teams of robots to go and conduct underground scavenger hunts? And that's just both a challenging problem, but also an exciting one. And so DARPA gets to go and hide these different objects underground in a variety of different settings. These are different types of, we call them artifacts. So imagine you're going on an artifact hunt, scavenger hunt in these underground settings, and then the robots have an hour to go and mostly by themselves figure out where they need to go look for these things, find them, and not just find them, but also report it back out and get scored for finding these artifacts. And so that's been a really exciting one, not only because it's robots underground, but also because it's a DARPA challenge. And I think the notion of a challenge is keenly exciting because it allows us to go and say, hey, there's a really tough problem out there, and then say, world, come think of the best solutions, think of your brightest solutions, and bring them to the table, or in our case, to the underground setting, and test it out. So yeah, it's been both invigorating and exciting to be a program manager for a DARPA challenge.
It sounds like a lot of fun getting to compete and then also getting to oversee the thing as you have. That leads us pretty well into our third question, which is, what are the applications of DARPA Subterranean Challenge, and what are the challenges that robots would face specifically in that challenge?
There are a number of different places where we might imagine wanting to send in these robotic teams, and specifically in those applications where it's pretty dangerous or highly uncertain what these robots might face in these underground settings. And so specifically those rescue missions where you might have a collapsed mine with trapped miners, and we now need to go send teams of robots to not only find, but also to pinpoint where their location. Or it might be in an urban setting after, let's say, an earthquake, and now you have folks that are trapped in subway stations or parking garages or other structures that might be underground. And being able to send humans is really just both risky, but also incredibly time consuming. So how could we take advantage of robotic systems to go into that mine or that underground setting, urban underground setting, or for example, in a cave-like environment? Cave rescue is also incredibly challenging, so and risky for the rescuing personnel. So can we use robots to help understand what's going on in that underground space, maybe illuminate it a little bit, and aid the rescue team to be able to do their job safely and effectively?
Yeah, okay, thank you. The second question to that one was, what challenges would robots specifically face, and like what do teams have to do to make sure that their robots compete well? Because I'd imagine that putting robots underground would be a different challenge than having them complete where you can see them.
Absolutely. There are a number of challenges that one might not immediately think of at first, but if you go underground, there's no GPS. So you won't be able to easily fly or drive or crawl or walk and always know where you are and that's a major challenge, especially if the goal here is to go find things and report out where those items are in that underground space. You kind of need to know where you are. Mm-hmm. So not having something like GPS means you have to rely on all sorts of other sensors or algorithms to be able to tell and track where each individual robot might be. And then also, once you find something, to be able to know where that object is in that underground map that you're building in your head. And so I think not having things like GPS is a major issue, but also you might be finding yourself underground without, let's say, light. You might not have easy access to a lit or sunlit area. And as a result, things look different when you're in the dark. Even if there's flickering lights or dim lights, that changes how you might need to look around, think about objects. What do shadows mean? So you and I might be really good at knowing that a shadow is just a shadow, but a robot might have difficulty not realizing that that's not a big drop off or a hole in the ground. And so thinking through different lighting is another major technical challenge. And then I think another one is that the underground tends to be a lot really difficult to maneuver and navigate around as well. So depending on what kind of underground setting, but certainly in most of these disaster response or rescue settings, there must have been some reason why that survivor got stuck in the first place. And that probably is what's making it hard for he or she to get out. So that same difficulty is likely to make it hard for robots to get in to go and find and rescue those folks. And so thinking through all of the different ways in which not knowing where you are, not being able to see or perceive the environment very well, and then also needing to climb, crawl, tumble, perhaps drive or walk around that really challenging terrain. I think these are some of the key challenges that we find in underground, and certainly those that we try to stress test in the SubT challenge.
That's amazing. A lot of my friends do high school robotics challenges like FIRST and VEX, and it's a very controlled environment, right? A 30 by 20 field, and everything's above ground. You can use vision. So a subterranean challenge poses so many complications that would be interesting to tackle.
Yeah, I really love those challenges, those competitions. I'm a huge fan and supporter of the robotics competitions. I did RoboCup once upon a time with robots playing soccer in my academic days as well. And I think there's definitely a strong role and need for that. And I think DARPA's vision here is to say, we need all of those great technologies that are coming from VEX and FIRST and elsewhere. And what can we do to build on top of all of that great technology to tackle some of these additional hard problems, such as the underground challenges that we face?
Yeah, okay, thank you. The next question we have is, you've done ground vehicle challenges with DARPA, subterranean challenges, and recently a launch challenge. If you had unlimited funding and no restrictions, what challenge would you do next?
Yeah, oh man, that's a great question, and one that I might pose right back to you and your viewers. I think there is so many really tough problems out there, and specifically those that are for robotics and robotic applications. So if you have a great idea and you want to come join DARPA as a program manager someday, then this is a place where you can plant that seed of wanting to understand these next grand challenges and try to solve that problem in that way. I'd say, to more directly answer your question, there's just so much more work left to do in robotics that there's a lot left to learn. And we've done, as you mentioned, ground and underground and maybe a little bit in space, but we still have a lot of other frontiers that we can imagine exploring. And so an air or a maritime ocean type challenge would be very interesting. And then perhaps not only thinking about where the robots need to operate, but what we want them to do. So I think there are a lot of really compelling problems, like how do we get robots to go up and down stairs very, very well, right? That's a small-ish problem, but there's some really interesting solutions that might be out there, just as an example. Or how do we take off, fly, and land, or deploy a ship, have it sail around the world, and then come back? Things like that. These are things that folks have been working on and thinking about. So what are the DARPA worthy and DARPA hard parts of those problems that would make for a really great grand challenge?
Yeah, those are all super interesting. I would love to see a maritime or air challenge. It's one of the most interesting things to see robots going into either space or underground or in the water, because you can't control it at all.
Yeah, and I agree. I think what DARPA is keenly interested in is finding those breakthrough technologies and being able to plant the seed for new ideas, and challenges are really great for helping to do that.
Yeah. Okay, our last and final question is, what advice do you have for youth interested in technology? And I know you touched on this with RoboCup and First Invex, but if you could go into more detail with what you did in your high school life and what you would want us to do.
Sure. Well, I think at the very high level, I love your audience, always asking questions, being that lifelong learner. And I know you may hear that a lot, but there's something particularly powerful about asking why and how, and finding both opportunities to exercise that question, whether you place yourself in clubs or activities, or even if it's as simple as finding mentors all around the world, as you have here, to identify and ask those questions of why and how. I think that's your two best arrows in your quiver of being able to be budding, rising technologists. I look at my two kids, two young kids, are budding engineers themselves, I'd say. Might be too early to tell, but nevertheless. And one of the things that I love seeing is that they always say why, and then I'll answer and they say why that, and this is what young children do. But I hope that our young technologists and myself as well never stop asking why, and I think that'll really take us really far, both in terms of the journey, but also maybe the answers that we might find at the end of that journey.
Thank you so much. That's really great advice, and I think that would be really helpful for all our audience to learn about mentors and then just keep asking questions.
Mm-hmm. Yeah, agree.
Yeah. So thank you so much for joining us today.